So hello everyone, myself Shreeram. So in this video, I am going to explain the asymptotic notations. So the definition goes like this. It is a mathematical way of representing the time complexity of an algorithm. So in asymptotic notation, three main things comes to the mind. So the first one is the big O notation. The second one is the omega notation and the third one is the theta notation. So in big O notation, it represents the worst case of the time complexity. So let me explain it to you by taking a graph. So this is basically an upper bound graph. So here the x-axis consists of n, which is an input variable, and the y-axis consists of t, which is time, and there are two functions, mainly c of g of l and f of l. So here k is an constant. So here f of n is expressed as f of n is equals to order of g of n. Here O is the big O, which tends to order, and there are two conditions, mainly f of n should be less than or equal to order of g of n, and f of n should be less than or equal to constant of g of n. Here c represents the constant. So here c must be greater than 0 and n must be greater than or equal to k, and k should be greater than or equal to 0. So this is the concept of big O notation. Thank you.
Hello everyone, myself Shreehari. I am going to explain about the omega notation. The omega notation is an algorithm analysis technique which is used to describe the lower bound of an algorithm's running time. It is the best case time complexity, which means that the algorithm will take at least some amount of time to finish its execution regardless of its input size. The equation for omega notation can be written as f of n is equal to omega of g of n. Let us consider a graph. Then in x-axis we can consider the input variable n, and in y-axis let us consider the time t. This line represents the equation c into g of n. This line represents the equation f of n, and the point of intersection this point of intersection is called as n0, and n0 is always a positive integer. Now, for example, if we consider the equation, some restrictions are there for this, such that f of n should always be greater than or equal to g of n for all n greater than or equal to n0. Let us consider an example. F of n is equal to 2n square plus n. Here we have to select the g of n. The g of n is the term which grows faster among all the terms. Here 2n square is the term that grows faster than n. So we have to consider only n square as the g of n. n square. And by replacing this with the first equation, we get we will get this equation. In this, we have to choose the value of c very carefully, because if for this example, if you consider the value of 3, then this will be false, condition will be false. So we have to take the value of c as 2 in here. This is the final equation of omega notation of example 2n square plus n. Thank you.
Hello guys, myself Shreyas and I am here to explain asymptotic notations. Well, what do you mean by asymptotic notation? It is the mathematical way of presenting the time complexity of an algorithm. There are three types of asymptotic notation. Big O, the second one is the big omega, and third is the theta notation. The theta notation tells us the exact time of an algorithm. The general formula of the theta notation is given by c1 dot g of n less than or equal to f of n, then which is again less than or equal to c2 or c2 dot g of n. Sorry. To understand further, we can use an example of the graph. The y-axis represents the time taken, the x-axis represents the size of the input variables. Here, this variable represents the C2 dot g of n. Here, the C2 variable is here. The C2 represents the second constant, and here the C1 represents the first constant, and the f of n and g of n represents the functions. C2 dot g of n. This is the upper one. And this region is called lower bound. These regions are called upper bound and the lower bound respectively. And we can understand the asymptotic notation and theta notation by taking an example to understand further. In this equation, we can let's assume that C1 and C2 equal to 2 and 3 respectively, and taking the function g of n as n square. Then, upon fulfilling a condition that is n greater than or equal to n naught, let's substitute the values of the constants. Upon filling the values of the constants, this equation fulfills and gets satisfied, and later becomes as n naught greater than or equal to 1. The general formula that's all. Thank you.